So as Phil mentioned, we're going to go through a little bit of a hands-on here. We have some drives, both an E3 and a P2 drive right here. We have the software we're going to go through. So the first step is downloading the software. So if we go to the website invertekdrives.com, there's a link here for software, and you're going to download OptiTool Studio right here. So this is where you also get the link for the mobile version if you want to do it on your phone. But we'll cover that a little bit when we talk about the OptiStick. But here you want to get the software to get started. So once we get the software, we'll switch over to that. So here is the software. Let me make sure this is working. All right, so we're in the software now. Now what we have, this is the general screen, what you're going to see. It's very similar to any Windows-based software. You have your save, your open, things like that, but very easy to use. So before we get into that, we'll switch over and look at the drives here. So the drives we have are E3 on the left and a P2 on the right. As we talked about before, they are very similar looking. As you see, they have the same buttons on the front. These two options have a slightly different screen between the two. Once we power them up, you'll be able to see the differences there. But the E3 is the more economy drive, as we said, slightly less features, but still just a very capable drive. And as you see, the differences, the main difference being the removable terminal strip here on the P2, whereas the E3, it's not removable. So, but otherwise, very similar, both very capable drives. So we'll go ahead and power them up here. And you can see the difference in the displays here. So here is just a segmented display. You can see all the codes. You can program it the same way as this drive. Just this drive, you can see a little bit more. This shows the voltage, the phase, the horsepower. It shows the P2 saying it's a P2 product. And it has the address number for when you get into the networking there. One of the features of the E3, as I mentioned, was this quick reference card. So if I pull this out, this is just a quick reference. You can see the basic parameters here, what they all mean, what they all do, just so you don't need to look for the book. It's all right there on the front of the drive. And same on the P2, and there's no actual pull-out card here. But if you look, this little icon here is the same as this icon. So if you push the center button, it brings up a help menu. So very similar there. So now let's go ahead and program this drive. So this drive is 100% out of the box. Nothing is programmed into that. So we'll switch over to the software. And what we'll do, we'll go through and set this parameter set to run this motor that we have right here. So this motor is a half horsepower motor, very small, and we know all the motor specs. So what we want to do is take the nameplate information, which is right here. You won't be able to see it, it's very small. But the nameplate information is the first thing we want to enter. So we'll come here to these first group, this group 1 parameter here. We will go, we know it's a 230 volt rated motor, so we'll leave that one alone. That's the default setting. The rated current for this particular motor is 1.2 amps, so we'll set that one. This is also a 60 hertz motor. So we'll set that to 60. And we know that this motor is rated at 1700 RPM. That's the nameplate rated speed. So now we know the drive is now set to learn what motor we're doing. So what we'll do is we'll come up top here and we're going to write these parameter sets to the drive. So the drive address is 1. That's the only one. So we'll hit OK. Whoops. Let's scan it real quick. It'll connect to it. Oops, yeah, let's make sure we change them. Yeah, it's just reading what's in there. So you can see it's talking to the drive there via the USB. So we have a USB connection kit here to the RJ45 on the front there. And then once it's okay, so it knows exactly what drive we're doing. So let's just go ahead and make sure we set these back to what we said, 1.2 amps. It's rated at 60 hertz, and it's a 1700 RPM motor. Okay, so now we made those changes. And now we can transfer it. So you'll see on the bottom, it'll transfer the parameters. And on the front here, you'll see right on the bottom, it'll say transferred successfully. There you go. So now it's ready to go. So now with just changing those 2 and potentially 4, depending on the type of motor you're hooking up, the motor is now ready to run. So if I come over here and press start, nothing happens. What's going on? Here's the reason for that. When you program these, the default setting, if you look at the software here, the program is set for terminal mode as far as the command source. So what that means, it's looking for inputs here from the terminal. For this display, we're not going to use any other external buttons. We want to use these buttons. So what we have to do to make that happen is change it to keypad mode. So once we make that change, we write that change. It'll do the same thing once again. And once the parameters are changed, we can now come over here and hit start. So this circuit has to be closed. So we hit start. So now that we hit start, it's like the motor's not running. If you can see that there, the motor's not turning, but it changed the display. So what's the reason for that? The default setting on this is to start is the previous setting it was set to. Since this drive has never been used, it was 0. So what we can do now, we can come over and we can crank the speed up to the max of 60 Hertz, which is the 1800 RPM that we set previously. And now the motor is up and running. So now you can come up here, you can do stop. You can start it again. You can adjust the speed as necessary, whatever you need to do. So just that simple to get the motor up and running. Now, all these other parameters that are in here are strictly to adjust for the application that you're trying to run. There's many different parameters, as you can see. One of the ones that's most commonly used is probably the acceleration and deceleration time. So we'll just show the example here. So if I start this one more time, right now it's set to 5 seconds and 5 seconds. So you can see there's a decent time span there for going up and down. But we can adjust that. So we'll stop it. And what we'll do here is we'll set this to accelerate really fast. So we'll do a 2-second acceleration and we'll have it slow down in 10 seconds. Okay, so we made those changes. And before we do anything, we have to write those changes to the drive. So once we write them to the drive, those changes will take place. And you'll see again on the front there, it says it was successful. So now when we press start, you can see how much faster it comes up to speed. And when it slows down, it's much slower slowing down. So simple changes like that within a matter of seconds, you can make all those changes. So they're the simplest functions to use right there. And that's on the P2. So as you saw, very easy to use. The E3 is programmed the same way. It all depends on how the user wants to program the drive, to program their app to use in their application. So very, very customizable there. Now, one of the things I mentioned last week within the P2 is the functionality that it has over the E3. It has so many more different features, can run different types of vector control and encoders and things like that. But you don't see that many parameters here. So where's the rest of them? So the way this software works is that they've been hidden for different users. So if the user wants to hide, if there's, say the OEM, for example, wants to hide the parameters from the end user so they don't go in and mess with the settings or things like that, as a default, this is all you can see. But if you go in and change this parameter to the special code that you can program in, so for the default, it's 101. Once you change that to 101, as you can see, it opened up more groups of parameters here. So now you have all these other parameters that are available to be changed for customization for the application that you're running. So it definitely hides things. It's a good way to hide settings from users that don't need to be in there messing with it. So 101 is one, then we do 201, it'll add even more. So you see we're up to 9 groups now, and you can see how many parameters we have to change and look at. So definitely keeps it very, very expandable for different level of users. Even so much so that if you change it to the highest one, you can shut off which parameters are visible within the group. So if we click one of these, and if we wrote these changes to the drive, they wouldn't even be displayed on here. It would scroll right through them. So again, it's more of a security feature to hide certain settings from certain users for whatever reason. So that's the parameter setting menu there. You can see you can access anything. You can add in virtual drives. If you weren't connected to one and you wanted to make your own parameter set, you can come over here and you can add well, since we're connected, it won't do it, but you can add a virtual drive, and without even being connected to it, you can do everything I just did there. So it definitely makes it very easy to use. Even if you're not next to a drive, you can do your pre-planning and make sure you know what program or what parameter set you want to make. So the next function we want to show is the monitor tool. So if we click this monitor tool, here you can control the drive all from your computer. You don't need to be by it. So we're going to enable the real-time monitor here. And now you can see it kind of changed. It sees what settings we're set to and things like that. So we'll go ahead and we'll bring this up to make it a little bit bigger here. But this is basically the same control panel that's on the front of the drive. So from here, we can start the drive. We can set the speed. You'll see it slow down. We can use this to slow it down as well. And then we can stop it. And since we have a slow ramp, it'll take a little while. So right there, it's just another useful tool for commissioning, for diagnosing, making sure it's working correct. You can see your digital input status here, whether they're on or off. You can see the power, you can see the current, things like that. So it's definitely a handy tool when you're commissioning a drive, very much so. So we go ahead and disable that. So now we can disconnect from it. Now the next feature we want to show is the one we talked about previously, is the built-in function block editor. So if we open the function block editor here, here's a sample function block that we created to control this motor. So this one, as you see, there's many different functions here that we can use. You can use logic functions, comparators, timers, things like that. But the gist of what the one we created here was, it starts and stops it starts the motor, and once it starts, it goes from 70 hertz down to 20 hertz, up to, it switches back and forth between 70 hertz and 20 hertz up to 6 times, and then it'll stay at 20 hertz. So if you need a multiple speed application for whatever reason, you can do that with this built-in PLC. Now, what we're going to do to program this, you can fully program it with the software, with the license activated. You can program it to the drive. But what we're going to do is show you the OptiTool stick here. So what we're going to do on this, we've previously created this program and the parameter set to go with it, and we put it onto this OptiStick. So what we'll do is we'll come over to the drive with the OptiStick. We'll unplug the wired version, put that out of the way, and we'll plug in the OptiStick. Once it plugs in there, you can kind of see it's booting up, and you can see the lights on the front there. So there's 3 touch buttons. There's an upload, a download. Once I unlock it, you'll see it. There's a download button and also an unlock button. So the first thing we want to do is unlock it. You press and hold that. So now it's unlocked. You can see upload and download. And what we want to do is upload the parameter set to the drive itself. So we're going to tap the upload, and you'll see the lines are going towards the drive and is now transferring the parameters that we created. Now, part of those parameters was the PLC. So that's on there as well. So now what we do when we hit our start button, which is this key here, you'll see it goes to 70. I'm not doing anything. The computer's not doing anything. It's all doing it on the PLC inside there. So you'll see it'll speed through 70 down to 20. And it'll do that until it reaches the counter that we put in there, which was 6 times. So you can see a standalone drive can now control itself without any external input from another PLC or another set of commands from another device. So standalone, good feature. So I'll go ahead and stop this. So there's the last one. So we'll stop that. And part of the PLC software is you can come over here and you can simulate it before you even download it to the drive. So if you go into a simulation mode here and start the simulation, digital input 1 is the same switch that we flipped, but if we turn that on, and well, let's see, we'll make sure our speed is up. So we want 1800 was the speed we wanted to go to. So once we turn that on, you'll see here, this will work through exactly what it was doing. And you can basically make sure your logic is working correctly. You can see this is now blue. It'll switch to red here when it hits that timer. So now that one's active. And then on the counter, you can see it'll count up to 7, it looks like here. And then we'll be able to control, and that's when it'll stop, when it gets to that final count. So here you can see what you can test this before you even put it to the drive, before you even put it in application. You can make sure it's going to work. And it'll even tell you down on the bottom here if it's not valid, if it's missing an input, if it's missing an output, etc. It'll tell you that before it even gets to the time to program it. So we'll go ahead and stop that. And the last function we want to show is the scope tool. So with the scope tool, let me switch back to the wired here real quick. With the scope tool, you can go in and you can see what the drive is doing for data analysis. So you want to see if it's running hot, if it's getting the right speed, whatever the case may be. you can log up to 4 channels worth of data. So what we'll do is we're going to do our digital input 1, which is our switch. That's our command switch. That's the status of that, essentially, whether it's on or off. We'll go to internal temperature, so we can log the temperature inside the drive. And then we'll go down to our motor speed. So motor speed will stay in hertz because that's what it displays on there. And we'll leave the 4th one blank. So now, once we get this started, we'll come over here and start the recording. So what you'll see here looks like a bunch of squiggly lines, but it's showing us what everything is doing inside the drive. So once I'm just changing the scales here so we can read it a little bit easier. So the yellow line is the speed, the red line is the digital input, and the green is the internal temperature of the device, of the drive itself. So we'll stop monitoring right here, and just to keep it quiet, we'll shut this off for us. But now you have all this data in front of you, and you can see what happened and when. So we'll come across here, we can see at this time during the acceleration time here, it was at 36 hertz right in the middle there, and it's still running at 45 Z, so we know it's good. Or if we come over here when it's decelerating, we know it's still at 45 C, so we're good there. So good tool for if you're trying to investigate what's going on with the application, making sure it's not seeing too much amperage, too much speed. If you want to overspeed, if you don't want to overspeed in your application, you can see exactly what it's doing. So definitely a useful tool, and it all can be done via the same wired kit that you've been programming with, monitoring with, and things like that. So it definitely can definitely be a helpful tool, especially for amp draw. If you're watching your amp draws and all of a sudden they're spiking up way over the rating for the motor, you know something's wrong. Either the acceleration ramp is too far, too fast, or even the decel ramp is too far, too fast. You can see it all right here, and you can break it down. You can zoom in a lot so you can really see what's going on there. So definitely a very useful tool there. Now, one other thing I wanted to mention on the parameter side here. We get a lot of questions about an auto tune. When do we have to do it? Things like that. So we'll go through the process of an auto tune right now. So with an auto tune, from a safety standpoint, you don't want to do it through the software. You want to do it when you're next to the drive. So what we can do, we'll have to do it in front. So what we'll do, just like we're programming the drive, but we'll come over here and we'll do an auto tune. So we'll bring up the parameters. And when the software is saying that, it's on group 4. So we're going to go to P4. We'll scroll all the way to it. Now, if we took some of these the visibility off on some of these parameters, you wouldn't even see them. But since we kept them all open, we will scroll through all of them. So it's P402. So we'll go to O2. Oops. And we're going to enable the auto tune. So once we do this, you'll hear a few clicks. The drive is basically sending signals back and forth to the motor to understand exactly what the motor has inside as far as the windings and things like that. So we'll go ahead and enable that. And you'll hear it. So you hear a little bit of humming there. And once it's done, it stops, so it's good. That's how long it takes to do the auto tune. Now, that all depends on the type of motor it's hooked to. Some motors will be a little bit longer, some will be shorter. Sometimes the shaft will move a little bit. It all depends on the type of motor, but you can do it when it's on the application. It's okay. It won't affect the data. It won't affect the auto tune. But what we can do now that we did the auto tune, I'll go ahead and read the parameters from the drive. So now it's going to read it what's on there and populate it on the screen here. And you'll be able to see some of the things that are different. So now the parameter set that's on here was the one that was on the OptiStick for the PLC functionality. So now that it's read it, we'll come over here so you can see it's using the PLC function enabled. That's in blue now. And in group 7, this is what we learned from the auto tune. So it learned the motor stator resistance by doing its own little auto tune there. So things like that is what the auto tune does. It learns specifically what the motor has in it or what the specs are of the motor so it can control it the best it possibly can. And I mentioned how the data here is turning blue. Whenever you change something in the software, it lights up blue. So it's a good reference for seeing at a quick glance, okay, what's changed? What's changed from the default value? So anything that has the blue highlighted on it here on the tabs or blue down in the data here, that tells you something has changed. So again, a very useful feature when you're trying to do multiples of these. Okay, what all did we change? We can look at it at a quick glance here. And along with that, you can come up here and you can export these parameters and save them to the computer. You can save them to a flash drive. And from the Bluetooth side, you can transfer them right to the OptiStick for many drives commissioning of the same thing. You could do it all at the same time. So it makes for quick programming of multiple drives that will be doing the same thing, or even as a backup moving forward. If one were to ever fail, you can have the file already saved, install the new one, download it, and you're up and running very fast. So definitely a good feature, very good, useful tool. So you saw the scope feature, you saw the PLC functionality and how you can control it, and then we controlled it with the software itself. So that's the gist of the OptiTool Studio software and using it there. Is there any questions?
Hi, Adam. One of the questions that we have, you mentioned auto tuning. Could you tell us what auto tuning is?
Tuning, that's where you put in your nameplate data. So that's manual entry. You've done that. Now there is some other data that's not readily available usually. Like, so for example, if I come over back to the software, this motor stator resistance, that's not nameplate data. That's something you could get that if you tested it yourself. If you took a multimeter and checked the leads going to the stator or what have you, you can check all that. You can get all that information, but the drive can do it itself. So doing that just further syncs up, further lets the drive know what exact motor, what the specs of the motor that it's running, to be able to give it that extra level of control and control it that much more accurately as far as speed, your speed changes, your feedback back and forth, making sure it's getting the best possible control for your application.
Perfect. And next question that was posted was, the OptiTool Studio definitely looks simple, but if I still have questions for programming a drive or multiple drives, who do I contact?
You'll be able to contact myself. My email will be posted here at the end, or you can, or we have a number of reps we can, or not reps, contacts for you to be able to support you there if you have programming trouble. But definitely you can always call us first and we'll make sure we get somebody that's in your area of the country. Okay,
perfect. Next question is, what communication interface are you connecting to the drive from the laptop?
So from the drive to, I'll just unplug it here and I'll hold it up here. So drive to the laptop right now is wired. So we have USB on the one end and then it's just an RJ45 to the front there. You could also use the OptiStick, which is Bluetooth. So if your laptop has Bluetooth, you could sync the Bluetooth up to the OptiStick and do everything I just did, wired or wireless, with the OptiStick itself. But I was using, for our purposes today, was a USB to the RJ45, which we call the PC connection kit.
Okay. Part two to that question is, how would you connect to the smaller drive for the E3 that you have on there?
So that would be the same way. We can do that real fast. I'll show you real quick. So using the same wired, we'll plug it into the RJ45 up front. And what we'll do, we'll scan the drive network. So it'll, because it's a different drive now, it has to find which one it is. So it found the one drive. Once it finds it, it'll download what's in there. And now you see here it's an E3. So it already knows what it is. Now this one's not wired to the motor, so I can't power the motor up, but it connects the same way. And once you tell the software that you're connecting to a different one, it'll show up and you can do all the same functions other than the function block editor with the PLC, since that's not option on the E3, but all the other functions, your monitor tool, your scope tool, all that works on the E3 as well.
Perfect. And that was the last question that we have so far.
Okay, any other questions? Okay, well, we want to thank everybody for joining. Special thanks to Adam. Great great presentation, great demonstration. Just a reminder, look out for some of our upcoming sessions. We will be posting some additional upcoming training covering various topics, including potentially additional Invertek topics, as well as PT fundamentals, so on and so forth. Again, we will be providing a recording of this webinar as a follow-up after this closes. And if you have any questions, please feel free to reach out to your local sales rep. You can access some of that information from our website, as well as from the email that we send you post webinar. We're going to hang out for just a few minutes. If you have any other questions, anything you can think of, we will stick around for just a few more minutes in case you have something that pops in. Otherwise, have a great day, and we'll see you next time.
We did have a question to come through. Have these types of drives been used for CNC machine spindles?
CNC spindles. I think we'll have to look into that. There's no reason they can't. It all depends on the motor they're controlling. Those type of applications are normally much higher speeds than like one that's right now, so go for about 1800 RPM. But there's some of the brushless DC motors and things like that, absolutely.
Your audio got a muffled there, so you may want to repeat that.
Sorry about that. So in CNC, they run higher speeds. They will normally see, like I said, usually going for about 1800 RPM. But using CNC, there's a certain motor, a brushless DC motor, but these lamps can run those motors, absolutely.
Hey, Greg, we'll try to get your email and shoot you a response. I know that audio was a little bad, but that hopefully you got the gist there.